Yes, we can see it, Mohammed.
Yes.
Okay, perfect. So please, I'd like to make this session as interactive as possible. Please feel free to, send your questions through chat, and we will have some stops during the slide deck to ask for questions, and I'll be more than happy to take any questions, and we'll definitely have follow-up actions on any needed further information around that. So let me start by discussing the hybrid cloud platform, right? Hybrid cloud is a term that we have been hearing a lot in the past years, so it's not something new. However, I think the IT architecture and the latest developments that are happening in the IT landscape have enabled hybrid cloud, further, and this is the core of what we're going to discuss today. So let me start by discussing why we need to, why customers and partners really are thinking today of hybrid cloud, and what is the ultimate business objective behind this. Now, we all understand that we live in a challenging world, and it's all about new innovations that everyone is coming up with, and the new business ideas and the new business trends that are shaping our current today and the future. So today, each and every business is under a challenge on how he can really maintain their customers and even grow their customer base. And they are under also a competitive challenge of how they can really continue to find value and deliver value to their end customers. They are also being challenged on how they can help bring and improve their customer experience. So basically, each and every industry today and each and every business is able to innovate and create more customer value and differentiation utilizing open source technologies with open culture. So we realize with our customers that open source technologies are now shaping up the IT architecture of today and tomorrow. And we see an exponential growth of enterprise customers and businesses worldwide who are going through more and more adoption of open source technologies, because open source is the base of all the new trends such as AI, machine learning, blockchain, container platforms, DevOps architectures, public clouds architectures are all powered by open source. So open source is a critical component of how organizations are building their new IT stack and how they are shaping their digital strategy going forward. And this is where Red Hat comes from. Red Hat is a leader in delivering open source to the enterprise. That's what we do. What we do at Red Hat is that we bring you enterprise class software, but we develop that software through an open source development model. Let me give you an idea about how Red Hat operates. So as you can see here in the center, this is the universe of open source, where there are over 1 million different projects, 1 million different ideas that are coming up, and bringing value and differentiation and, shaping the next IT architecture. So within these 1 million projects, Red Hat engineers and Red Hat management, participates in some of these projects, and we scan, these projects on what is really important to our customers, how these projects can impact IT. And we build on that, and we participate in these communities. And from these different projects that we contribute with, we integrate part of these projects, and we come up with our open source, products that you see on the, in the middle, like, for example, Fedora for Red Hat Enterprise Linux, like Overt for Red Hat Virtualization, RDO for OpenStack, and so forth. So we come up with these open source projects that are integrated out of these, different communities that we participate with. And then when we want to deliver our customers the end product that you get and you install on-premise, we make sure that it is tested, it is certified, it's bug-free, it is secure, it is documented and certified with all, hardware and software vendors that need to build the solution together with. And definitely we provide enterprise support and worldwide leading experience in terms of how we handle the deployment and the support and after sales requirements of these software. So this is how the model that Red Hat operates in. And I'd like to highlight that any development on our products goes upstream with Red Hat. So we don't build products and features in our products that remain only for Red Hat. No, we always contribute back to the community, and everything goes upstream to the product, and you will see it in the next version. So this is how Red Hat operates in. And if you look at the portfolio of Red Hat technologies that you see, at the edge, Red Hat doesn't only offer a Linux operating system, but we have a portfolio of solutions that range from virtualization technology into full OpenStack infrastructure as a service platform, into software-defined storage, and we have also, enterprise storage solutions for containers as well as for infrastructure solutions utilizing Red Hat Ceph and Gluster. We also have the Red Hat Lifecycle Management platform called Satellite, which enables you to have a fully stable, fully secure, and enterprise-grade standardized operating system platform for Linux in the enterprise. We also have other, definitely strategic products like the Red Hat middleware stack through the JBoss community, powered by the JBoss community for integration, for application automation, as well as for having certified languages and runtimes that can be supported on top of containers. We have definitely our hybrid cloud platform, the Red Hat Openshift, which is the core of our presentation today, as well as we have the Core OS and the CloudForms and the Ansible automation platform. And here I'd like to highlight the importance of Ansible as an automation platform to help you automate any of your day-to-day tasks and help you gain speed and minimize manual efforts, so you are much more efficient in your day-to-day tasks. So this is the portfolio of Red Hat, and as partnership with Red Hat, you have access to a lot of the innovations that Red Hat is bringing into the communities. Now, let's discuss some of the disruptive technology trends that we see today, and how these disruptive technology trends can impact, basically the IT architectures that we deploy in the data centers. The first disruptive technology trend that is being seen in the industry is that the virtual machine is slowly becoming technically obsolete, and it's slowly fading to obscurity. Definitely, I'm not saying that virtual machines are obsolete. I'm saying that there's a trend that it is technically obsolete. That means there are no more innovation, that is really have a major business impact with virtualization. The virtualization technology itself is mature, and cloud infrastructures will evolve from virtual machine-centric model into a container Kubernetes deployment. So whenever we talk into hybrid cloud and cloud infrastructure, we should always think that this architecture will be based on modern Kubernetes and container architectures. Okay, this is the next IT stack that is enabling hybrid cloud. And based on this trend, this is not something that we as Red Hat have came up with, right? It's the whole industry has agreed on this. And this is a snapshot of the Gartner Magic Quadrant in 2017. Okay, more than almost 4 years ago now, I think. And you can see the comments by Gartner, right? They are mentioning that more innovation is focused on container technologies that support developers and cloud services, right? So Gartner stopped and retired their Magic Quadrant for x86 server virtualization because for them, there's no more innovation in this trend, right? It's a mature technology, and more innovation is coming with the container platforms and Kubernetes architectures. So no need to invest in yesterday's technology. And today, it's virtualization is considered a commodity, and it's time for all customers to look at alternative virtualization technologies and look at where the real investment should be. It should be in the next IT stack in containers and container platforms. And this is, again, proven by how the industry is looking at container adoption. As you can see here, multiple reports. If you just Google, everyone says that container adoption is increasing. Containers are here to stay. It's just everyone is now re-architecting their applications on container platforms because container architectures bring value to the business. It helps definitely application developers become much more productive. It speeds up application development. It helps innovation in the enterprise, as well as it enables true hybrid cloud deployment of the application on top of on top of multiple public cloud providers. So hybrid cloud and multi-cloud becomes a reality with containers. So with that in mind, let's have a quick comparison between virtual machines and containers. On the left-hand side, you see the typical traditional architecture of virtual machines, which we have seen in the data center in the past almost 2 decades. And on the right-hand side, we see the architecture of the modern container platforms. And I just want to highlight the fact that, containers are not a new technology. Containers are a feature of the Linux operating system. It's not something that has been created recently. It's just a feature of the operating system that has been utilized, that has been, used in a standardized way, starting by Docker in 2011, I think, or around that time, and then it became mainstream, and it opened the door for the modern application packaging on containers. So let's look at the left-hand side. In a traditional virtual machine architecture, we used to, invest in hardware, as you can see in the bottom. And then you need to invest in a hypervisor technology. And then the hypervisor basically virtualizes the hardware. And then you are able to build multiple virtual machines. In each virtual machine, you need to install a complete operating system. And then definitely you need to deploy the application with the application dependencies, on top of it. And then you will have a full virtual machine running on top of that hardware. Now, this architecture, definitely it served its purpose. We couldn't have reached here without that architecture. Definitely it's something of value. But it had its limitations as well. Part of its limitations is that if you look at the virtual machine, we're talking about a heavy architecture relatively. Definitely, we're talking about the gigabyte size of application with the operating system, tens of gigabytes. So it's not really light. In addition to the dependencies between the application itself and the underlying operating system. So there's a configuration dependencies. There are some bits and byte dependencies between the application and the underlying operating system, which and there's also, another layer of dependency between the actual virtual machine and the underlying virtualization technology and hardware. So this makes the application packaging and deployment and portability between the development environment to the testing environment to QA to production and to public clouds. It's not something easy, right? It's not very smooth. It's not fully automated. It's not really modern and cloud native. Now, this caused developers to look at a better way and an easier way to package applications where these kind of frictions and dependencies are minimized. And this is where containers comes to play. As you can see here on the right-hand side with containers, you have definitely your hardware layer, but on top of that, a hypervisor becomes optional, right? You don't need to invest in a hypervisor. So this is the first thing of saving cost. And then all you need is to put a container host or a Linux operating system in this case, because containers are Linux. And definitely this is where Red Hat is coming from, our leadership position in Linux in the market. So we have a container host, which is based on Linux. And again, containers are a feature of the Linux operating system. So we are able now to leverage these capabilities of the Linux operating system and package applications in different containers. Each container is a separate process running only the application and the application operating system dependencies. And that's it. There is no complete operating system in each and every container, because all of these containers that are running on top of the Linux operating system share the libraries. So we have, with the container platform, basically the ability to virtualize, if you like, the operating system. While in virtual machines, we are virtualizing the hardware. Now we're virtualizing with containers the operating system, and each and every container is running an application instance completely isolated from the other And definitely, if you look at the size of these containers, they are in megabytes. They start and stop, in milliseconds. They can scale dynamically as your application requires. They are designed for modern cloud native architectures that scale out, and all they need to be deployed on top of on the hardware itself is just a Linux operating system, and you are able to deploy containers. So now, again, application portability from your development environment, from your laptop, for example, to the testing environment, to the pre-production or QA, and then finally to the production environment becomes a seamless, frictionless process that is fully automated. And definitely it can take you to the public clouds or multiple public cloud deployments. So this is why the whole industry is looking at containers as the next thing, the next IT architecture. And definitely containers enable hybrid cloud. Now, again, another comparison quickly on the left-hand side, the virtual machine. The challenge with virtual machine, as I mentioned, is that you have a complete operating system, the virtual machine. It's a heavy. It provides you only with static compute, static memory, which means it's designed to scale up, not to scale out. And definitely it has high resource usage, because if you have 10 virtual machines on a physical server, you're going to end up with 10 operating systems with these virtual machines. So it's heavy resource usage. While with containers, you get all the advantages of having container isolation, a separate process running, but you have burstable compute, burstable memory, scale out architectures, and definitely lighter consumption and much more optimized for low resource usage. From a management perspective, right? If we look at virtual machines on the left, usually when an application is packaged in a virtual machine and it's running in production, it's the responsibility of the IT ops. The IT operations need to own everything, right? The development of the application, the high availability, the security, the disaster recovery, etc. And only the application component or the application code is owned by the development team. While when we move to the right-hand side of the slide and we look at how containers enable completely separate authority and management of both the IT operations teams and the development team, there are different ownerships. The development team will own the full application and the container and the operating system dependencies, while the operations team will own the operation of the infrastructure and the container host layers. So completely isolated layers. Everyone is owning part of that application stack, and the responsibilities are clear. So it's easier to operate on a day-to-day basis. So when we're talking about hybrid cloud, right? To summarize, virtual machines are not portable across hypervisors, and they don't provide portable packaging for applications due to the friction, due to the internal configurations and dependencies that happen between the application and the underlying operating system, and between the operating system and that virtual machine and the underlying virtualization and hardware. And again, portability is not achieved through virtualization. There's a lot of friction, and a lot of prerequisites are needed to guarantee portability of that virtual machine, not to mention the size of the virtual machine itself. With containers, as we can see here, we are talking about standardized way of packaging applications that are lightweight, no operating system in the container, and all of these containers share libraries from the underlying operating system. So all of what is required for these containers to guarantee portability is to have a proper underlying Linux operating system underneath them. So conceptually, hybrid cloud is enabled through container platforms that is enabled, as we can see here, by Red Hat, in this case on Redel containers, which enables portability across physical, virtual, and any public cloud you want to deploy your applications on. So for Red Hat, as you can see here, our Red Hat Openshift container platform, the middle layer that you see in red, once you deploy and host your applications on Red Hat Openshift, hybrid cloud becomes a reality, it becomes guaranteed, and you are able to run these workloads on physical servers, on virtual servers, on private clouds, on public clouds, and on any public cloud, as we're going to see later in the presentation. Any questions so far? Okay, fine. So I think we can move forward. Now, when we talk about the second innovation that's
Sorry,
happening in the
we have questions on
yes,
the chat. Uh, they want to know some applications that can be put on containers, just as an example. Jiman has asked this question.
yes. So basically, when we talk about application migration into containers, definitely there are tools that help you migrate virtual machines into containers. But the first question should be: we need to assess your application architecture before, putting the right strategy on how we want to migrate your applications to containers. But to answer your question quickly, as a rule of thumb, okay, usually web applications are quick candidates for container platforms. Lightweight applications, cloud native applications. Okay, all of these are designed to be deployed in container platforms and to scale out. If we want to talk about databases, monolithic architectures, these are not application architectures that are suitable for container platforms. Okay, but again, this is where the role of Red Hat, who can come and help you assess your application landscape and any kind of application modernization that is needed to basically modernize the application architecture, move it from monolithic into microservices. We are able to help you in these kind of services and modernization capabilities to help you move into a container platform that enable you to deploy on a hybrid cloud. So again, if you have a strategy to move into hybrid cloud, then definitely a recommendation is to look at your application architectures. And before really moving these applications into a hybrid cloud or a public cloud platform, so instead of rehosting your application in a public cloud, this will not be a real hybrid cloud use case. We help you look at the application architectures, modernize these architectures, look at areas of optimization and deploy these on container platforms that will help you take you to any public cloud provider. So this is the approach that Red Hat takes. I hope I answered your question. And for the sake of time, I'll move on with the presentation. So the second disruptive technology trend is that about software, right? Again, we talked about the importance of software these days. Software is embedded in each and every technology and product, and almost anything we buy, from cars to toys to appliances. Today software is very important. It gives a lot of value and differentiation to each and every business. So definitely the software development, deployment, and architecture is evolving. So let's look at how these are evolving. In terms of the application development, we're moving from a waterfall methodology, the ability to develop applications in the old standard way, without full automation, without transparency between the development team and the operations team, where each one is living in their own world. We're moving into the DevOps world enabled by Red Hat OpenShift. What do we mean by that? We mean that with Red Hat OpenShift, we offer a complete application platform with full automation and features and products and technologies that enable full automation between the development team and operations team to help you speed up application development, deployment, security, and day-to-day operations. So we're moving from a waterfall application development into a much faster, optimized, automated way with full transparency between the development and operations team. The second evolution is happening on the application architecture. When we look at monolithic applications where we have multiple services, and of that application running in a single code base of that application. And we are unable to really modernize any of these services without stopping all the other services because they are deployed in a monolithic architecture. We're moving into a microservices architecture where we help segregate or re-architect that applications into multiple different services that are interconnected together, talking to each other maybe through APIs. And we are able to modernize and manage the lifecycle of each of these services separately. And thus, we are able to move into the cloud native way of developing applications and modernizing specific services without affecting other services. And we also allow other services to be shared across multiple applications as well. So this new architecture is also evolving. The third thing is the deployment of these applications. So as I mentioned earlier, we're moving from the physical world to the virtual world and to the container world. And as I mentioned earlier with the containers, It's all about, the features of containers, the portability, the lightweight, the standardized way of packaging applications. Definitely, it's helping us achieve DevOps and microservices architectures through containers. And with containers, definitely we are able to go from on-premise data center into hybrid cloud. So if we look at this in a summary, we look at the world of yesterday, the old architectures that brought us here, and we look at the world of tomorrow, right? Based on container platforms enabling DevOps and modern applications that are modernized through microservices and deployed across hybrid clouds. So this is where Red Hat comes to play. This is where we are able to help each and every customer to modernize their architecture that is based on yesterday's technology into building a new IT stack that is ready for the new applications that are deployed into the hybrid cloud experience, enabled definitely by open source technologies that are shaping the future of IT. So this is the role of Red Hat and Red Hat partners, is to help you through this transformation from yesterday to the world of tomorrow. Now, back to the question, this is a sample of how we look at traditional applications, and this is part of how Red Hat Consulting and the Red Hat middleware stack can help. So we can look at old monolithic architectures, as you can see here on the left. And through our application modernization consulting services, we look at re-architecting that application. So maybe part of that application needs to remain on-premise or in the old monolithic architecture, but other services can be decomposed out of that application and re-architected into microservices, and we are able to deploy these on public clouds. So we help you move from an old monolithic architecture into a modern, loosely connected microservices architecture, where these services can talk to each other through APIs, and event-driven architecture, where data, driven with AI and machine learning, analytics behind it and around it. We are all, enabled to, help you deploy these and leverage the value of this architecture. Again, monolithic to microservices architecture, an example of a payment, for example, service where in the old architecture, you have the registration service, the payment service, and the service inquiry all integrated through a single code base, where you are unable to modernize any of these services without putting downtime on the whole application itself. With a modern, loosely connected microservices architecture, these services will be managed separately by different teams. You may be using different languages, and you can act on these, with proper lifecycle actions on each and every application. And you can modernize each and every application separately from the other. So again, this is the modern way of looking at application architectures, and definitely we are here to help look at that. The third disruptive technology trend is about public cloud. Definitely public cloud is evolving to hybrid cloud enabled by containers and Kubernetes. So whenever we talk about public cloud, and I would like to highlight this as a very important, challenge to our customers when they want to move into public clouds. A public cloud should not be considered your end destination. So many of you, for example, have priorities to move to a public cloud. But definitely the second question we need to ask ourselves, is that public cloud provider our end destination? Or we need to have the ability maybe to move to another public cloud based on our business priorities. So this is where hybrid cloud and multiple cloud providers becomes our strategy, rather than really moving into a public cloud provider. Okay, so and in this sense, definitely containers and Kubernetes become the core of the hybrid cloud. And for those who doesn't know what Kubernetes is today, is the technology that enables container orchestration, which means it's the technology that has been standardized across all vendors, that about, all on-premise vendors or public cloud vendors, to manage, run, monitor the container platforms. So if you want to run containers, definitely you need a management platform for that to orchestrate the deployment, high availability, recovery, scaling, etc. So this is where Kubernetes is the technology that's standardized across all players for that. So it becomes the API of the cloud, because you find Kubernetes in Red Hat OpenShift, you can find Kubernetes across multiple providers, and different vendors. So today, anyone who has a hybrid cloud need to leverage Kubernetes. However, this is where Red Hat also differentiation comes to play versus other vendors. Since Kubernetes was first put as an open source project by Google in 2015, right? So Red Hat was the first vendor to offer an enterprise version of Kubernetes in 2015. While the whole industry was, not knowing what containers are, and they don't have an enterprise, product, and still questioning what are containers and what, the value they should bring, Red Hat was the first vendor to standardize on an enterprise product based on Kubernetes, and we started to deploy Kubernetes in production 5 years ago. Much faster, much earlier than any other, provider, and this gave Red Hat a big, a big leverage over other players in the market in understanding Kubernetes, in evolving that platform, in modernizing that platform, on understanding the platform, and also on building capabilities around that platform. And this is why, as you can see here on the slide, in terms of the market share, in terms of Red Hat strategy on Kubernetes, which we started with OpenShift in 2015. Today, we have over 2,000 enterprise customers running in production on Red Hat OpenShift container platform. We have customers in the MENA region. We have tens of enterprise customers, airlines, the largest airlines, most advanced banks, most advanced financial institutions, governments, and telcos already running on Red Hat OpenShift in production across hybrid clouds for years now. Nobody has this experience, and nobody has this kind of mature platform that is battle-tested, enterprise-grade today. Again, this is Red Hat's market share, showing you in comparison to others. And definitely, this is in 2019. Today, we are approaching almost 50% of the worldwide market share. So we are leading this new architectural wave of containers, and we have the most mature platform in the market today. Now, we discussed about Kubernetes and the importance of Kubernetes, but to really offer you an enterprise-grade container platform, there are much more capabilities beyond Kubernetes that are needed to run this platform, right? And this is why Red Hat is investing in a lot of projects in order to complement the Kubernetes experience of how you manage these containers across on-premise or across public clouds. So this is why also Red Hat is bringing more than 20 other open source projects to complement Kubernetes, in addition to the Red Hat Linux, which is needed for Kubernetes, to give you the best container platform that is enterprise grade, secure, with the full experience that you need to run on-premise, with all the monitoring capabilities, storage services, networking services, logging services, and reporting services that you need. So how we deliver Kubernetes to the market? We deliver this through OpenShift, which is considered the world's leading Kubernetes distribution, providing you the best enterprise-grade features and capabilities that is battle-tested, that is already running in thousands of customers in production today. So what we do at Red Hat is that we bring the lifecycle of Kubernetes as an open source project. And just to give you an idea about the complexity of the process, OpenShift contains definitely the core OS operating system underneath it, which is the Linux operating system. It contains definitely the Kubernetes project, which is a project that is updated every 3 months. And we also have the 20 additional or more services that are running on top of it. And we manage the whole life cycle of all of these products together to give you an enterprise-grade OpenShift release that you can install, tested, certified, secure, with full lifecycle management capabilities, with 9-year enterprise lifecycle SLA, and it is certified with hundreds of ISVs, also other hardware vendors and multiple software vendors as well. So this is how we deliver Kubernetes to the market in a much more advanced enterprise grade experience than others. Yeah, any question? Okay, so I think someone opened the microphone. Okay, so let's continue. So how can Openshift become your hybrid cloud platform? Now, as we can see here, talking about our container and DevOps platform based on Openshift, we are able to deploy that on your own data center. Openshift is available across multiple public cloud providers, and it can be your actual deployment of application on the edge. And on top of Openshift, because it's designed to support traditional applications, it's designed to support modern cloud native applications, as well as it is the best platform to support the new modern AI and machine learning functions. It becomes one modern IT platform architecture to support anything that you have today and tomorrow for your hybrid cloud. Okay, so we are able to deliver your applications in a completely modern way. Now, one of the questions we get asked is, right, how we are able to operate this Openshift platform. How is Red Hat helping us, with our day two operations? Well, definitely Openshift, again, it's a complete container management and deployment platform across on-premise and across public clouds. And it offers you a lot of security features and capabilities, storage services, networking services, monitoring, chargeback, and self-service architecture. But we also innovated on top of that with the concept of automated operations. What does that mean? It means, in a nutshell, that we are introducing the concept of operators, and we're investing in that concept with the operating framework as part of the open source community, which means that we are able to take all the day-to-day operations that an IT infrastructure stack operator does on a day-to-day basis. And we are able to replicate that through software by embedding these operator intelligence requirements into the platform itself. This is what we mean by automated operations. So with automated operations as part of the Red Hat Openshift, again, this is a unique feature of Red Hat Openshift today. We are able to automate the installation, the deployment, the full lifecycle management, including hardening, networking services, auditing, signing and policies, in addition to the day-to-day operations of, monitoring, alerting, upgrades, stopping services, starting services, making sure that the platform scales as the application requires. All of these operational requirements that are needed by traditional manual operations, we moved it into fully automated operations. And not only this, but also we created the concept of an operator framework where we have hundreds or more than hundreds of software vendors who have created their own operators. So their application services, once they are deployed on Openshift, they are also able to automatically update these applications as the platform updates itself. So we ended up with a platform that not only offers you automated operations, and it's fully intelligent, but it's also able to update all of the services that are running on top of it. The monitoring, the storage services, the networking services, even the applications, the middleware that is running on top of that platform, all gets updated as the platform updates itself. So we're moving into the next era of infrastructure operations with Openshift, and this is all coming from the contributions of Red Hat into the Kubernetes community. Now, Openshift doesn't only cater for the needs of the day two operations of the infrastructure team, but it offers the developers a complete a catalog of services for them to choose from, so they become much more productive. So we offer them complete middleware services and application integration services, as well as API management services that they can quickly tap to, so they are able to develop applications much faster way. So as you can see here, we can integrate with their IDE environments. We have ability to offer them languages, including Spring and Java, end-to-end frameworks. We are able to offer them full databases out of the box, integration with Jenkins, full automated pipeline capabilities, as well as automated builds, CI/CD pipelines, configuration management, application logging and metrics, and we help them to automate the full build, testing, and the deployment of their applications in a fully automated way. So again, the whole objective is to make the app developers self-sufficient with the most advanced tooling, technologies, and integrations needed for them to develop software and the cloud-native way and to deploy it on the world-leading container platform across hybrid clouds. Now, to give you a hint about the latest innovations of Red Hat OpenShift, we have recently introduced the Red Hat OpenShift Virtualization. So we understand that modern applications are containerized, and containerized services are carry a lot of benefits in terms of on-premise and in terms of hybrid cloud deployments. But we also understand that some services might still be suited for virtualization, a kind of packaging. So what we did is that we offered virtualization contained in a container. So we are able to package applications in virtual machines deployed on top of Kubernetes with Red Hat OpenShift. So for developers, they are able to develop applications, whether it's containers or virtual machines, deploy them next to each other, manage them from the same console, and deploy them across hybrid clouds. Okay. Now, definitely, we are not positioning this as a replacement to your virtualization environment. But if your requirements need a container platform, and you also need few virtual machines next to that application, to run virtual machines next to it, to run, for example, databases, to run specific monolithic architectures that are better suited for virtual machines, and you want to leverage the same management and capabilities of Kubernetes and hybrid cloud deployment, then Red Hat OpenShift brings you that today. Not only this, but also we're bringing serverless architectures, the ability to scale containers to zero, and based on specific triggers or specific streams of data, utilizing our integration Kafka streams, we are able to scale these serverless functions as your application requirements. And then once the actual triggers fade, we are able to scale back to zero. So today, Red Hat OpenShift offers you not only container platforms, but also virtual machines and serverless architectures. Again, it is the most advanced container and Kubernetes platform in the industry. Talking about hybrid cloud and choice, again, Red Hat OpenShift is all about choice. You can deploy Red Hat OpenShift today on physical hardware, or on virtualization technology, or on multiple public clouds, as you can see here, starting with AWS. We offer you on AWS both options, the Red Hat OpenShift dedicated, which is managed by Red Hat, or you can have a jointly managed offering, which is basically managed by AWS and Red Hat, or you can deploy OpenShift on top of AWS and manage it completely by you. Okay, so we have these three options available today on AWS and on Microsoft Azure, both a Red Hat managed option, a common managed option by Red Hat and Azure, as well as a customer managed option as well. So no other vendor offers you this kind of choice in terms of deployment and in terms of managed services around it. Also, we offer similar capabilities on Google, as well as on IBM Cloud. And on-premise, definitely, we have your customer managed option, or you can ask for Red Hat services to help you managing the platform, or training, or as engineers support for your platform. So we have all of these options for you to choose from. And again, this offers you choice, compatibility on any public cloud as your business requires. So with Red Hat, you don't have to go to a specific public cloud. You can go to any public cloud at your own will as your business dictates. And this is the value that Red Hat brings versus others. Now, I don't want to go into the details of the Red Hat OpenShift container architecture, right? But again, we offer the most comprehensive container platform in the industry, starting from the below. We offer you with Red Hat OpenShift definitely the Linux and the Core OS, the world-leading secure Linux in the market, integrated with the Kubernetes layer, and integrated with all the cluster services, on top of Kubernetes with the full automated operations that I discussed earlier, with over-the-air updates. What is that? What does that mean? It means the platform updates itself over the air in a fully uninterrupted way. And as the platform updates itself, all the services that are running on top of it with the operators will update themselves as well. It's a very similar experience to how you update your mobile. Once you update your mobile, all the actual applications running on top of it will be updated as well. So this gives you the same experience, the same cloud experience with full monitoring, networking services, and reporting capabilities. Also, you see in light blue all the specific services that we deliver to our developers, right? So developers have a core basically interest for Red Hat in the OpenShift platform. So we offer them, Virtual Studio Code extensions, IDE plugins. We offer them complete developer CLI with the full languages, frameworks, and integrations that are needed for them to become productive. And also we offer them, CI/CD pipelines, as well as chargeback and logging, and as I mentioned earlier, serverless functions available off the box. Now, what I want to talk about in specific is the layer on top, which is the multi-cluster management. So we understand that as customers modernize their applications, their application architectures will be deployed in containers, and these containers basically will grow, and you need to manage these containers, and you will end up with multiple deployment of these containers. Like, for example, the web tier will be, for example, on AWS, while your data services will be on-premise, and other parts of that application will be maybe on Microsoft Azure. So you will need a platform that will be able to manage multi-clusters, multiple Kubernetes platforms. And in this sense, Red Hat is already having a 2-year product today to manage multiple Kubernetes clusters across different providers. It offers you the unified hybrid cloud experience from today. So with Red Hat, what we call it, the advanced cluster manager, okay, the layer on top. With advanced cluster manager from Red Hat, again, you will have a unified view of all your Kubernetes clusters deployed across on-premise or on any public cloud, with a single view to deploy, manage, install, and basically update these clusters and monitor these clusters and report on AWS, Azure, Google, vSphere, OpenStack, and bare metal. So this is the most mature multi-cluster manager today in the industry. And as you can see here, it has a very nice graphical user interface, predefined connectors to all the public clouds, single-click deployments, monitoring, lifecycle actions, all embedded into the platform. And this is why we achieved the worldwide leading market share by Forrester, last quarter for the multi-cloud container development platform. As you can see here, we achieved a very, very strategic position, based on multiple criteria, including our ability to build once and deploy anywhere. We make that a reality. So again, deploy your application once on Red Hat OpenShift, migrate it to Red Hat OpenShift, and you can deploy it anywhere, manage it anywhere using a single pane of glass. Again, we achieved high marks for customer service and support. We achieved also leading position for for pioneering the operator model, which I mentioned earlier, with the ability to the platform to update itself over the air. Also, we have the most widely deployed multi-cloud container platform in terms of maturity, in terms of features and capabilities, and definitely the developer experience and the automated operations is, again, one of the leading features that are giving us this position. We also definitely understand that many of our customers are going into more AI and machine learning architectures. And we understand, as you can see here in the slide, that the life cycle of an AI machine learning project includes, or starts by setting the goals by the business. But we have also multiple stakeholders, including the data architects, including the software developers who's going to develop the machine learning models, right? And then the actual development of the machine learning models, as they mature and go into production. So we monitor and continuously provide feedback to the outcome of the machine learning model. It mimics a lot the software development lifecycle. So with Red Hat OpenShift also, we are able to provide you not only with the hybrid multi-cloud platform, but with the complemented by the Red Hat middleware stack and the Kafka capabilities and image streaming and integration features and the application automation, we are able to help you develop in a fully automated way the whole machine learning software tools and enable you with data services to access multiple databases and data lakes, etc. And we have all of this certified to run on compute acceleration like GPUs and TPUs and others as well. So we have this fully enabled by Red Hat, and we have full partnerships with the leading AI and machine learning softwares today to help you simplify the deployment, optimize the scaling of the deployment, as well as develop software in a much faster and optimized way, and definitely deploy it on any public cloud or any hardware that is needed. So we have these certifications and partnerships already available today. And again, talking about partnerships with the AI machine learning ecosystem, you'll find Red Hat certified to run on almost all the known AI and machine learning software vendors today. So please, if you have any AI and machine learning software or a project, make sure that you discuss with Red Hat and that software vendor to make sure that you are running your project on the best platform that will deliver the best performance as well as the best deployment and experience for this use case. So we have these integrations and certifications as part of the AI and machine learning. And we get a lot of questions about what differentiates Red Hat OpenShift from other Kubernetes services in the public cloud. Yeah, we call them the XKS services, whether it's from Amazon, whether it's from Google, whether it's from AWS, etc. Again, I always compare Kubernetes itself as the project as buying a car with only the engine, the gear, and the wheels. Nobody buys a car with only engine, gear, and wheels. You need the full experience. You need the full enterprise experience. You need the seats, the dashboard, the security, the airbags, the entertainment system, the exhaust system, etc., etc. So this is what Red Hat OpenShift brings. It brings a lot of features on top of the actual Kubernetes to give you this enterprise-grade experience. Now, if we compare this to the XKS or the other Kubernetes products from public cloud vendors, it requires you, number one, it's a lock-in to that cloud provider, and nobody wants lock-in today. And the second thing is that, to be able to have this kind of enterprise experience, you need to do a lot of integrations and maintenance into that actual public cloud provider services and hardware infrastructure and monitoring tools and application services and databases, etc. So you will end up doing a lot of integrations on your own, by yourself, supporting it by yourself, and you will be owning the full security responsibility for these integrations. So it's not the full enterprise experience. You will have a lot of operational headache. You will have a lot of integration headache, and you will end up with a platform that is not really enterprise grade, installed as one platform, supported and maintained as a unified platform. Okay, so take care into that. The public cloud Kubernetes is not like OpenShift. OpenShift has a lot of single sign-on integrations, security credentials, lifecycle management, built-in registry, storage, integration with any kind of storage network that you have. So the openness of the architecture and the security that's embedded and the integrations that are already available out of the box with OpenShift is not something you will find with other public cloud Kubernetes. So again, multiple services will be priced differently, multiple services will be supported differently, and you will need to own all the integrations and maintenance of all of these services that you will be doing. I would like to end up with, highlighting the Red Hat services for OpenShift. Definitely, we have the Red Hat Innovation Labs. So this is like a consulting services from Red Hat, where we offer a kind of a residency, kind of consulting, where if the customer has a specific requirement, or if you need to modernize a specific services, or you need your team to be enabled on the modern way of developing applications, or if you have a specific idea in mind and you need to come up with a specific, MVP, minimum viable product, we have a residency program where our engineers from Red Hat will sit with your team, and we will discuss over a period of time on your, basically on your business requirements, business goals, and what are the technical criteria that are needed to achieve that. And we can sit together and work together on achieving this kind of, product. So this is a kind of a Red Hat Open Innovation Lab. The idea of, enabling your teams to go beyond technology into the actual way of deploying these new services or new applications or new products that you want to come up with. On the right-hand side, we also have the Red Hat Container Adoption Program, which is basically our ability to assess your container requirements, also assess your application landscape, and come up with an approach on how we can help you, move into the container adoption journey, and we can achieve a phased approach together on how we can build that journey together. So again, I'd like to end up with the Red Hat OpenShift customers. We have, again, thousands of customers running in production today. It's the most mature platform. We have customers in the region, in each and every country, in the MENA region, in the Middle East, in UAE, in Saudi Arabia, in Oman, in all countries with telcos across all sectors. Reach out to the Red Hat teams, and we will be happy to share with you all the success stories that we have with Red Hat OpenShift. And finally, why customers choose OpenShift? Simply because it is a trusted enterprise Kubernetes. It gives you a cloud-like experience everywhere, and it empowers you to do different use cases, and it helps your developers become much more productive, and we support the latest innovative open source technologies. With that, I end the presentation, and if anybody has any questions, I'll be happy to answer. And these two links are for anyone who wants to try and test OpenShift. Please go here, and you have a free tutorials on OpenShift, and you can download free demos as well.
Yeah.
Sure.
All right. Thank you so much, guys, for attending this presentation, and have a great day. Thank you.
Thank you all. Have a nice day, everyone. Thanks.